goal of this lesson is to show you how to find the derivative of the inverse of a function. And I didn't write it in the title, but this is really about finding the derivative of the inverse of a function without having to find the inverse of the function. Because in some sense, if somebody asked you to find the derivative of the inverse, I mean, I guess you could find the inverse and then take its derivative. But as you guys should be aware, there are certainly some problems where it's difficult, if not impossible, to actually, formulaically find the inverse of a function. So it's nice to have another way around this. And there's a conceptual component to this, and I want to show you that, and I'm going to show you that. But I really feel like that conceptual component is led by the formula for this. So I'm going to write down the formula. So the formula says that if you have the inverse of some function and you want to know its derivative at some value like a, it will be equal to 1 over the derivative of the original function evaluated at the inverse of a. And that looks crazy, but there's actually a way that I can make it look a little bit prettier if I just sort of change some notations. Suppose this is an or if g of x is the inverse of f of x, then, so all I'm saying here is instead of using the f inverse notation, if we just up front said, hey everybody, g of x, that's the inverse of f, then the formula looks a lot nicer. It says that g prime of a, the derivative of the inverse at a, is equal to 1 over the derivative of the original function at the inverse of a. Right? And it sort of, I want to try and show you where this formula comes from, so I'm going to try this in the next 2 minutes, and if it doesn't sit well with you, the two examples that follow I think are pretty clear. So let's just say, for instance, that we wanted to know, and I'm going to use this graph here. I'm going to call this the original function f, and this one is the inverse, which I'm going to call g. Let's say that I asked you, what is g prime of 1? Right? What's the derivative of the inverse at 1? According to the formula, it would be 1 over f prime of g of 1. Alright, and I'm going to detail this in the next slide, but in short, the first step is going to be, what is g of 1? Right? Now, based on this picture, you could say, oh, I can tell what g of 1 is. G of 1 is 2. But that's only really easy if you know what the inverse is. What if you didn't actually have that red line? Right? What if we just knew that they were like, what if the only thing we actually knew was this picture of f? Well, we can do something kind of sneaky, right? This point here has a sister point on the original function, right? When we plug 1 into this, like when we use an input of 1 to the inverse, that's the same as getting an output of 1 on the original function. So, in other words, when we say what is g of 1, that's effectively the same as saying f of what would give me 1. I mean, that's what it means to be an inverse, right? So looking at the picture, you can see, oh, well, if I were to plug in 2 to the original function, I would get back the 1 value. So that effectively tells us that f of 2 is 1. In other words, my g prime of 1 is 1 over f prime of 2. So then I just have to find out what the derivative is, what the slope of this tangent line is. Right? And based on how I've drawn it, it looks like this thing is up 1 and over 2. Right? So this will be 1 over 1/2. So the slope of this inverse appears to be 1 over 1/2 is 2. And it's neat, if you come back to the picture, you can see that this slope here does indeed seem to be about 2. That was a terribly, terribly non-straight line, but I think we've got the idea. That was a pretty long theoretical intro. I really feel like in the next couple of slides I'll be able to make that more clear, but I do hope you guys have some picture of what this looked like. So let's get to that first example. So this first one, a pretty standard example. Let f of x be x cubed plus 2x plus 1, and g of x be the inverse of f of x. And I want us to find g prime of 13. I really feel like your best bet here is to start with that formula and sort of start by plugging things in and starting from the inside. So the formula that we had was that g, which is the inverse, g prime of 13 is equal to 1 over f prime of g of 13. Right? Now, I guess, I suppose I'm giving steps here, right? Step 1 is to write down the formula. Right? Step 2 is basically to evaluate this thing. Right? So evaluate the g of 13, right? And it's important that we recognize what that means. And we talked about this in a previous lesson, in the previous place. If you're plugging 13 into the inverse, think about that. Plugging 13 into the inverse is the same as getting 13 back from the original function. So when I'm saying what is g of 13, that's effectively the same as when is the function equal to 13. Right? So I'm effectively saying what is the x value that will make this thing true. And this one's difficult to do by hand. In this case, I was kind of expecting us to just sort of do it by guess and check. If you plug in 1 here, you get 1 plus 2 plus 1, which doesn't work. If you plug in 2, if you plug in x equals 2, you'll end up with 8 here, another 4 is 12, and 13. So x equals 2 is the value we were looking for. Now you may be wondering, like, wait, so do we have to just guess and check on these? Sometimes you do. When you do have to do guess and check, it's really going to be easy. Like, you'll probably guess it in the first few shots. At any rate, so we started step 1 by writing down the formula. Step 2, we evaluated the thing that was inside. And we did that by setting the original function equal to that and finding the x value where it happens. So now I've simplified, right? This is g prime of 13 equals 1 over f prime of 2. Right? So now what's step 3? Step 3 is to find the derivative. Find f prime of x and plug in the value. Right? So I'm running out of space a little bit here. If my original function was x cubed plus 2x plus 1, it means f prime of x, the derivative, is 3x squared plus 2, which means f prime of 2 is 14. Right? Checking my notes. Yeah, 14. So great. Put that into the formula. That means g prime of 13, the derivative of this inverse that I'm looking for, is 1 over 14. And you're done. Right? So just like I explained, I know it was a theoretical and difficult, but on the first slide, I was explaining this idea that in order to find this thing, what we really do is we recognize that the slope of the inverse will be 1 over the slope of the original function, right? But at what value? It's sort of at the sister value to the thing that we have. 13 came from 2, so we plug 2 in and find out what that slope is. Okay? So this is one style of problem where you're given a function and you're sort of working through functions. The other version of the problem, the other way that I thought of that this could be asked, is using a table, and so we'll see how that one goes. So that's in the next slide. Okay, so let g of x and g prime of x be continuous functions, and let h of x be the inverse of g of x. So I'm switching up the letters a little bit to give us some practice with that. So g is basically the original function, and h is the inverse of that. And the table here is giving us several values of g of x and g prime of x, and I want us to find h prime of 2. So understand this here effectively means find the derivative of the inverse. And note, that's what this entire lesson was about. That's what this whole thing was supposed to be. So like we said in the previous problem, the steps are staying the same. First, let's write down the formula. They want h prime of 2. Great, how do we do that? It's 1 over the derivative of the original function. Now in this case, h was the inverse, and g was the original function. So this is going to be g prime of, and then here's where I put the inverse of the value that we're looking at. Right? That was supposed to be step 1. Step 1 was simply write down the formula and figure out what those things are. At least I think that was step 1. Yeah. Step 2 was then start from the inside. What is h of 2? What is h of 2? Ran out of space there, but there we go. Well, what is h of 2? H of 2 is effectively saying when is 2 equal to the original function. Right? When is 2 g of x? And hopefully we can see that fairly clearly. G of x is equal to 2. G of x is equal to 2 right here when x is 5. So x is 5. Right? So what is h of 2? H of 2 is effectively 5. H of 2 is the x value that this output comes from. Right? So now I have h prime of 2 equals 1 over g prime of 5. And great, now we just, we have to take the derivative and plug that in. Fortunately, we just got a table, right? The table says the g prime of 5 is negative 1/3. So that means h prime of 2 is 1 over negative 1/3, which is negative 3. And that's it. These are the two ways that I can envision asking this question. There may be other ways, but all of them are simply going to rely on us having this formula and us sort of like figuring out this inside thing, plugging that into the derivative, and simplifying. Okay, so that's all I have for this lesson. Please download the homework assignment. Do at least one of each of the 2 types of problems to make sure that this lesson meshed with you. If not, watch it again. I'm expecting us to be done with this on Monday and to be able to get to the rest of the lessons in the rest of the week. So I hope you enjoy the rest of your weekend, and I'll see you in class.